A manufacturing company is undertaking a safety training program in an effort to reduce the number of days per month that workers miss due to head injuries. The table shows the scores on a safety awareness evaluation for 10 workers before and after the program. Can it be concluded at the 0.05 level of significance that the program is effective in raising safety awareness? Now, since we have dependent sets of data, and we know that they're dependent because the same subject was used to generate two different data values, we are going to conduct a paired t-test. And when we conduct a paired t-test, this will actually turn out to be a single sample t-test, where the sample consists of the correlated before and after differences. And we could orient that in any way we want. We could say before minus after or after minus before. Let's, in this case, generate our data set by doing after minus before calculations. So now in this third row, we have the after minus before calculations. 71 minus 65 is 6, 54 minus 42 is 12, and on down. So this becomes the sample that we will conduct the t-test on. So now let's think about what this t-test is going to look like. We specified in our differences after minus before. And the question was, is the program effective in raising safety awareness? So if it's effective in raising safety awareness, then we would expect for the after values to be greater than the before values, which means that this would be a positive difference. So we would expect a right-tailed test in this case. Our significance level is 0.05, so all of that would be concentrated into the upper tail. So we would need to get a critical value. And what we are hypothesizing here is that this mean difference, so now we're using a symbol here, mu for capital mu for population mean, but this little subscript d means the population mean of the differences. And so right here in the center it would be 0, and anything to the right of that would be positive. So now we need to design our hypotheses. The null hypothesis should be that the mean difference is equal to 0, and the alternative hypothesis should be that the mean difference is greater than 0. So we'll have a positive critical t-value, and if we're going to do that, then we're going to need to know the number of degrees of freedom for this test. The degrees of freedom in a matched pairs test is n minus 1. And I just used the term matched pairs. And we refer to it as matched pairs because these data values represent a particular subject, like say person number 1 and person number 2, person number 3, and these data values that they generated are matched up. They're after and before data values. We can use the TI-84 calculator to find our critical t-value. In order to do that, we'll click Second, Variables Distributions, and go to number 4, Inverse T. We are conducting a one-tail test with alpha equal to 0.05. So this value should be 0.95 since it's all concentrated up in one tail. And our degrees of freedom will be 9. Since there were 10 matched pairs, and the number of degrees of freedom will be 1 less than that. So the syntax then in a TI-83 or 84 calculator that does not use the menu to prompt for these values, your order would be the area, the accumulated area, and then the number of degrees of freedom. Hit enter. And we get a critical t-value of 1.833. So if we round to 3 decimal places, we have a critical t-value of 1.833. Now, if we want to find our t-test value, we'll do that using these after minus before values. In order to use the TI-83 or 84 calculator to calculate this t-statistic, we'll first need to enter these values into a list. So I'll click Stat and then 1 in order to get into the editing of the lists. Then I have typed them into list 1, and these are the differences. Now, in order to calculate the test statistic, we'll click Stat. We want to go over to Tests, and then we want number 2, since this is a single sample t-test, since we're testing on the average difference. And then the calculator wants to know, are you going to tell me some data that is in a list, or are you going to tell me some statistics that have already been calculated? Well, we have our data in a list, so we'll make sure that that is highlighted and hit enter. And then we will come down and make sure that our mean difference is 0. We have our data in list 1, so I'll click second 1 to make sure that says list 1. Leave the frequency at 1, and then I want to choose the correct alternative hypothesis direction. And since this is a one-tailed test to the right, it'll be greater than. Highlight that and hit enter. And then come down and hit calculate. Now we can see that we have a t-statistic of 3.736 if we round to 3 decimal places. Also note that our p-value is 0.0023 if we round to 4 decimal places. Now let's take a look at what happened here. Our t-test value was greater than our critical value and landed us up in this rejection region. So our conclusion would be to reject the null hypothesis. Also note that if we paired up our alpha and p-values, we would wind up with the same conclusion. Since the p-value is less than alpha, we would again reject the null hypothesis. So our conclusion would be something like, sufficient evidence was gathered at the 0.05 level of significance to conclude that the program is effective.